All right. So the first thing I want to point out to you is you got 2 homework due tonight, 6-1 and 6-2, and then 2 more homework due on next Tuesday, 6-3 and 6-4. The test, some of you will really receive the graded test, and I'm still grading the test. But the key is in D2L, so I'm sure you where was it at, so you know where in D2L is at. So some of you will look at where is in D2L, so I showed you where is it at. So let me show it to you. Come on. So go to the D2L, the class D2L website, and then on the corner here, there should be a content, materials, and then go under content. And you guys will see the midterm right over here, and the key is right down here. So the midterm key is posted right here. So if you have, if you need to see the midterm here is the key. So you can see what you did right or wrong. But once I finish grading, it should be done by hopefully tomorrow or Thursday. That's what I'm shooting for. And then you guys will get the grades and everything. And if you have any questions, let me know. So so this is the key. So on 6.1 question 39, that's the one that someone asked me this question about the car windshield wiper. So let's talk about this one and then see what you guys have up there. So this question number 39 is asking for a car rear windshield wiper rotates 135 degrees. The total length of the wiper is 23 inches and the length of the wiper blade is 13 inches. Find the area wiped by the wiper blade. So this one looks something like this. So we have a windshield wiper, we have a blade, and this blade, if you it will rotate 100 and sorry like that. So this will rotate 130 degrees. Sorry. So it goes something like that. There you go. So it will rotate 135 degrees here. And the whole mechanism is 23 inches. And the blade is 13 inches. So the question is asking for the area of the white by the blade. So the green one, because this is the blade. So this question wants you to figure out what is the area for this. Now, we have a formula to find area of a sector. The area of the sector in this case is 1/2. It's a pi. Let me see. Oof. I told you once I get sick, everything I forgot. 1/2 pi r squared. No. The 1/2 pi r squared. No. 1/2 theta r squared. Sorry. I think that's the right formula. Shoot. Hey. Sorry about that. I think it's that formula is correct. Is that the right formula, guys? 1/2.
I can double check, but
that's correct, right? Yep, 1/2 theta r squared. That's correct. So so in this case, in order for us, but your theta, this is a main part that a lot of students get wrong in the homework or in the test. This theta has to be in radian. So this is one of the mistakes that students forget to change this into radian. So do you guys, how do we change degree to radian?
uh,
135 degrees times with what? Pi over 180 degrees. So we're going to change this into, pi over 180. So we're going to change this into radian first. So that is the first thing you need to know. Now, this is a tricky question. It's because you need this green area. So in order for us to get this green area, first you have to find the mechanism for the whole thing, which is 23. And then you have to minus this little piece. This small piece. But this small piece, they don't give you the length of this. But we know this is 13 inches. So what is the length of this one? And you know the whole mechanism is 23. And if this is 13, so this must be 10 inches. So you have to subtract these two in order for you to get the green one. So let's find the area of the red one. So the area of the red one is 1/2 times with this 135 pi over 180, because that's your theta. And then your radius is 23 squared. So this one is all calculators. That's my calculator. Ooh. Uh-oh. Shoot. Sorry about that. Press the wrong button. There you go. You guys here?
Yep.
Okay, sorry, press wrong.
Yep.
So, told you when I get sick, it's not fun. 0.5 times 135 pi divided by 180 times 23 times 33, which is the 23 square. So this came out to be that small. That doesn't look right.
I got a 623.1.
I know, that's why this one's. So I'll show my calculator. 0.5 times, and then I show you the shortcut after that. Always a shortcut. That's my pi symbol. About 180 times 23. So this one came out to be 600. This one is 600 and something, right?
Yeah, for your numbers, it was 623.21.
13. Yeah,
For me ish.
Yep, something like that. Now we do the same thing for the orange one. So it's exactly the same, but you just need to change your radius. Your radius in this case is gonna be 10. So changing my radius to 10. And that will give me 117 something. 0.81. And then next, we just need to subtract these two up. So you take this minus with 623. So this is roughly around 505 point something. So this is how you get this answer for question 39. But there's a shortcut. The shortcut is very easy because you find out that the half is the same, the theta is the same, the radius is not the same. So what you do for the shortcut is you just do the subtraction. So you do 1/2 theta r1 square minus r2 square. So if you guys want to do this next time, you do not need to find the area for the red one and then the area for the green, the blue, the orange one, and then subtract it. You can actually do just direct substitution. So you just do like a fact, just put all this in there, and you will find out that it's easy to do. So the r1 square is the biggest one. So in this case, it's 23. And then the r2 square is the orange one, the smaller one, which is 10 square. And you will still get this answer if you just do this way. So that is the quickest way to do it. So this is how we do question number 39 in 6.1. You guys have any questions on this one? How
On this question or on this assignment?
Any
On
questions?
6.1, Could we just do 35 really quickly?
On 6-1?
Yes. Question
Okay,
35.
35. Okay. Yep. Good. You guys are asking all these questions. Okay, so what happened in question number 35 is you had to find the distance between the two cities. The radius of the Earth is 4,000 miles, and the cities are the same longitude. What is the same longitude means that one city is due north of the other. So example is San Francisco and Seattle. If you look at the map, they kind of like one is north and one is south. That means they're the same longitude, but the latitude is different. This is the latitude here. So so in order for us to find the distance, so again, the Earth is round. I hope so, not flat. 4,000 feet is the radius. 400 miles is a 4,000 miles is the radius. It looks like Seattle is a bit north. So Seattle is here and San Fran is here. And they give us these two latitude here. So the question wants us to find the distance. So what is this distance is? Okay. The distance formula is given us by r times theta. Okay, so this is how you figure out the distance is r times theta. R is 4,000. We know that r is 4,000 here. Theta is this one. We doesn't know the theta. So we need to find theta. But once you find your theta, then you can plug it into here and then you will be able to find it. But do not forget that this theta is also measured in radian. Okay, so a lot of students didn't do that. So make sure you transfer to radian. So the first thing is, how do you figure this one out? Is you take this latitude and you subtract them. Because in order for us to find this theta, you have to subtract your latitude. So we take the 47 degrees for 37 minutes and then 18 seconds. And you have to subtract this with 37 degrees, 47 minutes, and 36 seconds. So subtracting is a bit more weird because like here, if you subtract this, you cannot subtract because this is too small. So you have to borrow 1 from 37. So this is 36. But when you borrow 1, you have to add 60. Because every minutes you borrow is 60 seconds. So when you add 60 plus 18, this is 78 now. So what is the difference between 78 and 36? This is 42. Yep. And then the same thing happens to the other one because 36 cannot subtract from 47 because it's too small. So you have to borrow from 47 degrees, so it becomes 46, but you have to add 60 here. So every time you borrow 1 from 1, you have to add 60. So this will become 96 now. And then you subtract 96, take away 47 is 49. And then this one you can subtract nicely. I think it's 9 degrees. Okay. So the theta is difficult to find. So once we got the theta here, but unfortunately this is a DMS mode. So we had to change this into degree mode. And then once you finish to change this degree mode, you have to change this into radian. Because your formula has to use radian. So you guys know how to remember how to change the DMS to degree mode? Anyone know?
Yes, I'm just looking back over my notes to get it exactly.
Make sure you know how to do it. It's not that difficult. So this one, you just take 9 plus 49 divided by what? Every degree has how many minutes?
60.
60, yep. And then 42, and every second is how many seconds in a degree?
60 again.
3,600.
3,600, yep. Don't forget, we don't change the minutes, we change everything into degree. So use your calculator and type this out. Do not round, please, no rounding. This is what a lot of students do is, oh, I'm gonna round this up. You will get it wrong. So this will give us 9.828, a lot of threes, right? So this is how we change the degree here. And now we have to convert this into radian. And how do we convert degrees to radian? Multiply by pi over 180. So you take whatever you have on your calculator times pi over 180. So that, again, no rounding. That will came up to be 0.171536. So this is where you plug inside your theta. So what do you do next is you take this number, multiply, because you're gonna find the how far is this, the distance. So you just need to take this number times with the radius of the Earth, which is 4,000 miles. So take, again, no rounding, just take the answer and times 4,000. So that came up to be 686.147. So the question wants you to be nearest mile, so it's 686. So this is how we do these kind of questions. You guys all right there?
Mhm.
So the main part about here is to get the theta, which is a lot of work. So make sure when you subtract, you borrow 60. Borrow 1 becomes 60, and then this is a DMS form. You have to change the DMS to degree and then the degree to radian, and then plug it back into there. Then you get yourself an answer in this case. Okay. Yep. Any more questions on 6.1?
I'm good on 6.1.
Okay, now 6.2. Questions on 6.2? Anyone?
What was it? It was just a second here. It's taking a while to load. It was,
Yep. I know. So I have everything set up when you guys. Guys,
we could just go over. Oh, go ahead.
Yep, go ahead. Yep, you know one.
Just
I'm
28. 28.
28. Okay. This one. Okay. And if you have more, just let me know, because I don't know why I got 50 students. I got 2 students coming today. I understand it's snowing, but you need to come to school. You can go to your house. All right. The values want
Snow
to
Day
know.
doesn't really stop digital lectures.
I'm sorry?
Snow days don't really stop digital lectures.
No, Snow Day will not
I
stop.
was just trying to make a joke.
Yep, I know what you mean. Yep. If you come to school, I understand, but you know, for this, but biologists want to know the width W, the river property set instrument for the experiment from point A to point downstream 100 feet to point C. And it's determined that the theta here is 56. How wide is the river? So this one, they want you to do, this is theta, this is 100, and this is X or W, what do you call it? So you have to figure out which one should we use here? Should we use sine, cosine, or tangent? So don't forget, sine is saw, cosine is car, and then tangent is tor. So this one, if you look at this one, the theta, the one that this X is opposite, and then the one across next to it is adjacent. So which one you think should be used? Sine, cosine, or tangent?
Tangent.
Toa.
Yeah, TOA. So you do not need to use Pythagorean to figure out the hypotenuse. So this is tangent theta, but we know theta in this case is 56, right? This is 56 degrees. So tangent 56 degrees is equals to opposite, which is x in this case, or w, over by 100. And then you multiply this by 100 after that, because you want to solve for x. So then use your calculator and figure out what is 100 tangent 56. Some of you get the answer here wrong is because your calculator is not in degree mode. So make sure that your calculator is in degree mode. For example, is see this calculator have DEG on it. So it can be RAD or the R symbol. So if you have an R symbol, it means that you are in the radian mode. You have to change it back into degree mode. So this one, I can click on it, become and then grad. So we're going to use degree mode gradient. So we're going to use degree mode in this case. So a lot of students who get this wrong is because they didn't change your calculator in degree mode. So make sure you have the letter D on it, or the DEG if you have a degree mode. So 100 times tangent 56. So that came up to be 148 point something, right?
Yep.
256. So into one decimal place. So this is 148.3. So that's how we do question number. Is that 28, right? You asked?
Yes.
Yeah. So that's how we do question number 28. So make sure you guys know when you do this, make sure you know which sine, cosine, and tangent we have to use in this case. Yep. Grace, I know you just got in. Do you got any questions for me? Grace? Anyone have any questions beside 6.2 on 28? Yes, you will get these kind of questions in your finals. Make sure like this kind. It's not that tough, so make sure you know how to figure this one out. Because 6.3 is a tough one. Anyone?
Nothing really else.
Okay.
Me anyways.
Anyone? Grace, Parker, Ryan? No. 6.1 on 35. Do I just did that? Maybe not. Let's see. 35. Yep, I did 35. Grace, can you watch back the old videos that I have? I will repost this video again, Grace. I just did 35 just now before we move on to 6.2. So I watched I will post it, so watch it. Because right now I need to do some anything else, Grace, beside that question? Because I need to go to 6.3 because 6.3 is a difficult one. All right. So we're going to talk about 6.3 trigonometric functions of any angles. Now this one is tough. The reason why I say it's tough is because now we don't do only 90 degrees. Now we do more than any angles we have. So before we continue with this any angles, you need to know the special angles for 45, 30, and 60. So I don't know if you guys know this or not, but this is very important. Sine, cosine, tangent. So let's talk about, do you know how to find sine? 45 degrees is pi over 4. 30 degrees is pi over 6 in radian. And 60 degrees is pi over 3 in radian. So these are all in degrees and radians. So does anyone know how to figure out sine 45, cosine 45, and tangent 45? This is back in 6.2 before. We call it the exact value. So I'm going to show it to you now. So in order for us to get a 45 degrees, it is going to be an isosceles triangle. Means that they have to be the same length, the same legs. So I'm going to put this as 1 and 1. So this will be a square root of 2. How do I find this square root of 2? Is because of a Pythagorean theorem, a squared plus b squared equals to c squared. So 1 squared plus 1 squared is 2. So this is square of 2. So as usual, when we do this, like on 6.2, we do SOHCAHTOA. So sine 45 degrees. So sine is so which is opposite over hypotenuse, is 1 over square root of 2. But I don't like 1 over root 2 because there's a square root in the denominator. I have to rationalize it, become root 2 over 2. So this is sine 45 degree is root 2 over 2. Cosine 45 degree is adjacent over hypotenuse. This is also 1 over root 2. But if I rationalize this, this is root 2 over root 2. The same thing. So sine 45 and cosine 45 are exactly the same. Tangent 45 is opposite over adjacent, which is 1 over 1. So this is 1. So tangent 45 degrees is 1. Now, so this is something that you guys need to know, very important. The next one that we talk about here is the 30 and 60 degrees. And the 30 and 60 degrees, we're gonna use something special to draw this triangle. I'm gonna use the equilateral triangle. And I'm gonna cut this triangle, equilateral triangle, into half. And I'm gonna put every single one of these 2 units. That means this one will be 1 each. The reason why I use equilateral triangle is because that all the angles also has to be the same. So they all will be 60, 60, 60. But this one I'm going to use because it's cut into half. So it's going to be 30 each. So what I'm going to do here is I am going to concentrate on half of this triangle because it's a right triangle. So I'm going to concentrate on half of this right triangle. So so now we need to figure out what is this side here. So again, we will use Pythagorean theorem. A squared plus b squared equals c squared. This will be a square root of 3. Because c squared is 4, a squared is 1, so 4 minus 1 is 3. So this is 3. So now we can do the 30 and 60 degrees using this triangle. So for 30 degrees, which is this is 30 degrees. So sine is opposite over hypotenuse, so it's 1/2. Cosine 30 degrees is going to be adjacent over by hypotenuse, so it's root 3 over 2. And for tangent 30 degrees is opposite over adjacent, 1 over root 3. And I have to rationalize this. This is root 3 over 3. Okay. And then for 60 degrees, now we look at this one for 60 degrees. So for sine is opposite over adjacent, opposite over hypotenuse, root 3 over 2. For cosine 60 is 1/2, which is adjacent over hypotenuse. And for tangent 60 is just root 3 over 1, which is root 3. So this is how we find the sine, cosine, tangent for 45, 30, and 60. This one is something that you guys need to memorize or you need to know. And then since you know sine, cosine, tangent, then you can also figure out what is the reciprocal of it. So sine will become, what's the reciprocal of sine? Cosecant, secant, or cotangent? What's the opposite of sine?
Cosine?
No cosine. No, we don't have. Just secant, cosecant, or what is opposite of sine? It's going to be cosecant, right?
Yes.
And what is the opposite? What is the reciprocal of cosine? It will be secant, and tangent will be cotangent. So how do you figure out all this value? Is you take this and flip around. So cosecant is the opposite of sine. So it's, I don't flip this around, I flip the one before I transform. So this is √2. Same thing with secant, which is a reciprocal of cosine. So 1/√2, this is also √2. Cotangent for this is just 1, because when you flip 1, it's still 1. So this is for the 45 degrees in this case. And I'll do the same thing for 30 degrees. So I flip the 1/2. So if I flip the 1/2, it's 2. I flip this. This is 2/√3. Then the rationalize it will be 2√3/3. And then for cotangent, I flip the 1/√3. This will become √3. Then same thing happens for 60 degrees. So I flip this. This will become the same as what we did just now. 2/√3, which is the same thing as 2√3/3. 1/2 become 2. √3, when I flip it, become 1/√3. So this is √3/3. So these are all the 45, 30, and 60 for all 6 trigonometric functions. And this is very, very important, because if you doesn't know this, 6.3, you're having a hard time. Okay. So now we talk about 6.3. So 6.3 is what based on here. So in 6.3, now we talk about all angles. So, so this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. You guys know that already. So in quadrant 1, all of the trigonometric functions are positive. In quadrant 2, some of you learned this in your high school. All students take calculus. Something like that. All students take calculus. So for quadrant 2, S stands for sine. So sine and cosecant will be positive. The rest of it, cosine, tangent, secant, cotangent, will be negative. In quadrant 3, all students take. So T is tangent, and so tangent and cotangent will be positive here. And in quadrant 4, calculus, which is cos. So cosine and secant will be positive in here. So the rest of them will be negative. So this is what happens if your angles fall into these quadrants 1, 2, 3, 4. Okay. So so when you guys want to find an angle, a value, exact value, it's all based on these 3 numbers: 45, 30, and 60 degrees. And from last week meeting, Zoom meetings, 45 degrees, last time when we talked, we also have three more angles, because 45 is in quadrant 1, right? So what is 45 degrees in quadrant 2? I think it's 135. Quadrant 3 is 215. Yep. 225, not 215, 225. And then 315 is for quadrant 4. Do I teach you how to find the radian for this case? As I told you, everything here must be over 4, right? So 135 is what? Anyone know what's 135 degrees in radian? It has to be over 4. Do I teach you this before? Remember last time I say you cannot be reduced this. So if you have 2, you cannot have 2. The reason why you cannot have 2 here is because 2 over 4 can be reduced. So the next one is what? 3 over
3
4.
over-
And then what is the next one is 5 pi over 4. And then 7 pi over 4. I think we did this on last meeting, right?
I don't believe so. No.
Okay. So so for 45 degrees, this is in quadrant 1, this is quadrant 2, and this is quadrant 3, and this is quadrant 4. And for 45 degrees, how we know this is because each one of these is a 45 degrees here. So that's the reason why that when you have a 45 degrees, this will be pi over 4. And then the next one here is 135 degrees here. And this one, you cannot, you figure out this by not reducing with 4. So everything has ended with 4 with 45 degrees. So 2 pi over 4 can be reduced. So the next one is 3 pi over 4. And then 4 pi over 4 can be reduced. So it's not going to be the next one. So 5 pi over 4. 6 over 4 can be reduced, so that this one should be 7 over 4. So this is for 45 degrees in this case. We can do this for mostly all these 3 angles here. So the next one is 30. So if this is 30 degrees, then what is 180 take away 30? This is 150, right? And then for this one, you add 180 plus 30, 210. And then this one, you subtract 360. 30 take away 360 is 330. So these are all the angles for 30 degrees. And 30 degrees must be over 6. So this is pi over 6. And then everything here has to be over 6. And they cannot be reduced. So this one, you cannot put 2 pi over 6 because 2 and 6 can be reduced. You cannot put 3 over 6 because 3 over 6 can be reduced. You cannot put 4 over 6 because it can be reduced. So this is 5 over 6. The next one is you cannot be 6 over 6 because it can be reduced. So this will be 7 over 6 because it cannot be reduced. And then 8 over 6 can be reduced. 9, 6 can be reduced. 10, 6 can be reduced. This is 11 over 6. So this is again for 30 degrees. And then we got the one for 60 degrees. So if you have a 60 degrees, then we will do 180 take away 60 is 120. And then 180 plus 60 is 240. And then 300, because that is 360 minus 300. And all the 60 degrees is over 3. So this will be 2 pi over 3. Now this one cannot be 3 over 3 because it can be reduced. So the next one is 4 pi over 3. And then this is 5 pi over 3. Now the reason why I bring up all this is because in this section 6.3, we do all these circles. So what happens if I want you to find what is tangent 315 degrees? So this is the one that we will do in 6.3. Okay. So in order, and if you use your calculator and press tangent 315 degrees, and they give you the answer, oh, you get an answer. But usually I don't want you guys to use a calculator. I will show you why, and then you will get wrong if you type it in. So what you do here is first you figure out 315 is in what quadrant, and what angle is what is a reference angle that goes to 315. I will tell you what's a reference angle. So 315 is in quadrant 4, right? And for 315 is reference to, this is called a reference angle. So the reference angle can be either 45 degrees, 30 degrees, or 60 degrees, because 315 fall into here. So it is going to be a 45 degrees in this case. So what you do here is you look for tangent 45 degrees. So tangent 45 degrees is 1. But since it is in quadrant 4, only cosine and secant is positive, so tangent is negative. So for tangent 315, your answer is negative. So every time when you have this kind of angles, this kind of questions, you have to figure out this by doing what quadrant it belongs to and what is the reference angles for this case. Let me give you another one. Let's do secant of 7 pi over 6. So how do we do this? Is first what quadrant it belongs to, and then what is the reference angle. Now, 7 pi over 6 is this one. So it belongs to quadrant 3. Reference angle, anything over 6 is going to be 30 degrees. So what we're going to do here is figure out what is secant 30 degrees. So this is secant. 30 degree is this one. So this is secant 30 degrees, which is 2 root 3 over 3. And then quadrant 3. Now quadrant 3 only positive belongs to tangent and cotangent. So secant in quadrant 3 is negative. So your answer in this case is negative 2 root 3 over 3. But if you use your calculator to do this, first you have to change this to radian form first. So you have to change the radian. Do we have a secant in here? I don't think so. We have secant, right? You only have cosine. So a lot of students, when you use your calculator, you don't have a secant. So they use this symbol cosine minus 1. This is wrong. Okay. So a lot of students think secant is cosine minus 1. That is wrong, because a cosine minus 1 is the inverse of cosine. So in order for you to do this in your calculator, you have to first change the radian. That's the important thing. And then you have to do 1 over cosine of 7 pi over 6. Where is my trigonometry? There you go. So you got a cosecant here. Oh, that's fancy. So I'm going to use the same thing because you don't have that. So 1 divided by cosine of, oh my gosh. Okay, let me redo. This is a lot more work. 7 pi times 7 divided by 6. And then you do the cosine of this. Sorry, this is tough. And then you do 1 over it. Forget about it. I hate this calculator sometimes. Computer calculator sucks. 1 over cosine of, what you got? You guys got something? Then you do this. Because you need to know how to do some of the questions in the online homework. But if you do that, cosine of, you will get a bunch of decimal. 1 over secant, this one, 7 pi over 6. What happens to my calculator again? Something wrong here. So when you do this in your calculator, they give you negative 1.1547. This is wrong. This is what I want. It's called an exact form in this case. So make sure you guys know how I want the exact form, not the decimal form. So I'm going to show you some homework that you guys have to do, because that is where the main part of this. We'll do this later on. We'll do the one that I'm teaching you how to do. Okay, there you go. Friend of yours, what is, there you go. So I want you guys to figure out what is sine 330, cosine 330, and tangent 330 without using a calculator. Should be. So when you do this, question 23, what I suggest you to do is first figure out what quadrant is 330 and what reference angle is 330. Anyone know?
So quadrant 4, the reference is 30 degrees.
So it's quadrant 4 is 30 degrees. Yep. So quadrant 4, 30 degrees. So 30 degrees is this. So your answer is here. This is your answer. So for sine is 1/2. But in quadrant 4, which one is positive? Sine?
Cosine is positive.
Cosine is
Secant
positive.
is positive.
Yep. So, but here asking, and so sine and tangent will be what? That will be negative. So this will be negative 1/2. This will be √3/2. And then this one will be negative √3/3. So this is how it's not too difficult. Once you get hang on to this, to this mode, because this is something that I really, really want you guys to know, because a lot of students struggle with this. What happens if it's like here 675? Does anyone know what to do with 675? Question 24.
Subtract 360.
Yep, subtract 360. So that will give me, so 675, take away 360. 315. So this is the same as 315. So back to the same thing. What quadrant is this belongs to? And what angles, reference angle it goes to?
Quadrant 4 again, and the reference is 45.
Yep, so 45. So this is your answer then. This is your answer because you say it's 45. And you say it's quadrant 4. So quadrant 4, again, sine is negative, cosine is positive, and tangent is negative. So for this is negative √2/2 here. Cosine will be √2/2, and tangent will be -1. So as I told you, this table that I draw early on is so important. This whole page is so important, is because it will really help you to do this kind of work. So if you guys want to take a picture of this, I know it's a bit icky and stuff, but it's or if you have written down notes, which is good. So if you, I save this. Let me save this. This is trick. Exactly. And what we call this is exact value. Okay. So if a question is asking you to find what is the exact value, means they want in square root form. They don't want in decimals form. Okay. I'll post this in D2L also, so you guys get it. This one, same thing, 3π/4. So when you have 3π/4, anything over 4, as I told you, is what kind of angle? Reference angle. Anyone? Over 4? What's a reference angle for over 4?
45.
Yep, anything over 4 is 45 degrees. And then 3π/4 is in quadrant
2.
2. So this one is also exactly the same answer as we have here, but now this is in quadrant 2 now. But for quadrant 2, which is positive, sine, cosine, or tangent? Anyone? Quadrant
Sine.
2. Sine is positive, but the rest is negative, right? So for this answer is going to be √2/2 for sine theta. This one will be a negative √2/2, and this one is still at -1. So make sure you guys know how to do, because mostly I really want you guys to know this. And again, chapter 6 we will use, and chapter 7 we will use this a lot. So chapter 6 and 7 and 8, 6, 7, yeah, 6, 7, 8 will use this quite a few. So make sure you guys know how to find this what we call as exact value. Okay. All right. I'm gonna move on to the next one. Okay. So next thing I want to bring it out is the first few questions, the top questions here. Now, in order for you to do this kind of questions, like question number 3 here, you have to use your SOHCAHTOA. Okay, so they give you this 3/4. So this 3/4 means that your x is 3. So if you look at your this is your theta, so it become a triangle actually. So your x is 3, so this is your x is 3, and your y is 4. So this is gonna be 5. And how do I find 5? Is using Pythagorean theorem, a² + b² = c². And then over here now you can use your SOHCAHTOA. Okay, so do you guys know what is sine theta in this case? Using SOHCAHTOA.
It's going to be
Sine
4/5.
4/5. Yep. Cosine
3/5.
Tangent
3/, is it going to be 4/3 or 3/4?
4/3. So it's opposite toa, opposite,
Yeah, okay.
over adjacent. So that's why it's SOHCAHTOA. And then what happens to find cosecant, secant, and cotangent? So what you do? You flip all this one, right? So this will become 5/4, right?
Mm-hmm.
This will become 5/3. And then this will become 3/4. You guys okay here so far?
Yep.
So it's the same thing as what you did in 6.2, right? But now I'm going to teach you guys something else. So we know this 3 is your x value. 4 is your y value. And in this case, 5 is your radius, because from here, if you think this is a circle, this 5 is actually your radius. In 6.2, we say adjacent, opposite, and hypotenuse. But in 6.3, we will say this is your x value, your y value, and the radius. So when you do sine theta, is actually y/r, because it's opposite over hypotenuse. Cosine is x/r. And tangent is y/x. And then for cosecant, secant, and cotangent, you switch all this around. So this is r/y, x/x, r/x, and this is x/y. Okay. So so if you have so this is what we did in 6.3, is you have to find that. So you can so when you guys do this in your homework, there are 2 ways you can do it. Like one way, you can transform it into a triangle like this, and then do your SOHCAHTOA. Another way is you just make sure you find you should give you x and y. You have to find r using the Pythagorean theorem. R is the square root of x² + y². And then after that, you use this formula of y/r, x/r to find sine, cosine, tangent. Same thing happens here. Okay. So there is a shortcut I want to point out to you guys when you guys look at this these numbers. This is what we call as a triplets. So if you know 3 and 4, the other one has the hypotenuse has to be 5. So like this 3, 4, 5. This is something really gonna help you because you do not need to calculate using your you don't need to use your Pythagorean to find it. The other one is 5 and 12. Does anyone know what is 5 and 12? What is the hypotenuse? Does anyone? It will be 13. This is what we call as the triplet. So if you Google search it, if you Google search Pythagorean triplet, you will get a lot of them. Wikipedia. So so like 3, 4, 5. So this is a triplets. You see that? 3, 4, 5, 5, 12, 13. That's why I use 8, 15, 17, 7, 20, 24. So make sure you guys know. I think about this. Don't do all. I think this is the first 3 will be the one that I will. The first row is the one that I will recommend you to know. So make sure you know this row because it will help you. You do not need to use Pythagorean theorem to find out. So 3, 4, 5, 5, 12, 13. And then the other thing about these triplets that you got here is if I multiply everything by 3, it's also going to be a triplet. So what happens is 9, 12, 15 is also another triplet. If I want to multiply this by 2, 6, 8, and 10 is also a triplet. So don't forget that when you see this, it's just the base of it. So you can take this whole thing and multiply by 2, multiply by 3, multiply whatever number you want. It is still going to be a triplet in this case. So make sure you guys so they call it the non-primitive. So it's like 6, 8, 10 is a triplet too. So make sure you guys know this because it's going to be really help you to do the triplets. So you do not need to find but if it's not like this one, then you have to use your Pythagorean theorem to find your answer. You guys doing all right here so far?
Yep.
Okay. Now, last thing before I let you guys go is undefined case. Yes, there are some undefined case in this case because as you remember that because this is all has a fractions. So to make it undefined, you know that your denominator cannot be 0, right? So what happens in this case is your radius cannot be 0 because when you draw a circle, you need to have a radius. So this case, sine and cosine will always have a defined case. So defined case means that it is that means you can have a number. So any number that means it's defined for any domain and range in this case. But for tangent, x cannot be 0. Now, can you give me a coordinates when x is going to be 0? So it's like 0 something, right? 0, 5, 0, 3, -2. Do you know where was that at? 0, 5 is over here, right? Or 0, -2 is over here, right? So if you have such case, this is for 90 and 270. Or pi over 2 and 3 pi over 2. So what I want to point out to you guys here is when you want to do tangent for these two numbers, 90 or 270 degrees, your answer will be undefined. The reason why your answer will be undefined is because your denominator will be 0. Like 90 is what? Let's say 5 over 0. It is undefined. Same thing happens to secant because secant, you find out that your x is also 0. So if I want you to find what is secant 90 degrees, your answer is also undefined. Okay. So these are the one that I want to point out to you. Or secant 270 degrees, your answer is also undefined. So these are the few that is undefined. That is for tangent and secant. But if you look at cosecant and cotangent, you find out that your y is 0. So that means that your coordinates is either at 0 or 180 degrees. So if I want you, or 360 degrees. So if I want you to find what is cosecant of 2 pi, your answer is undefined. The reason why cosecant 2 pi, your answer is undefined is because your coordinates is right on the y value, the x-axis here, so it's undefined. Same thing with the cotangent of pi. Cotangent pi is 180, and again it's on here, so this is undefined here. So what I want to point out to you guys here is, if your angle falls into the quadrant, means anywhere between here, here, and here, and here, then you refer to the previous table that I do, the 1/2, the √3/2, and all those fractions that all this we just did just now. But what happens if your angle falls right on the y or the x-axis? So if an angle falls right on the y or the x-axis, then you have to use this formula, the one that I point out here. So this is formula when your angles fall on the x and y axis, and then the undefined case happens. Don't forget, for tangent and secant, the undefined case happens for 90 and 270 degrees. And for cosecant and cotangent, the undefined case only happens for 180, 0 or 180 degrees. So these are the undefined case, and it's very important in this case. And this is just 6.3. I think the next section, 6.4, is about graphing. Okay, so 6.4 is about graphing in the sine and cosine function. So that one also might take another class for that. Yep, 6.1 graph of sine and cosine. So I will post some videos how to graph sine and cosine function. It's a bit more difficult. And if you guys need help with this, you need to set a one-on-one Zoom with me. And yes, these things are getting really, really, really difficult in this case. Good. So make sure you guys, if you guys need help, either send an email to me, set a one-on-one Zoom. You have 2 homework due on this tonight, which is 6.1 and 6.2. And you got 2 homework due on next Tuesday, which is 6.2 and 6.4. So we'll concentrate more on this. And yes, things are getting really, really tough on this section. So it's not going to be easy anymore. All right, so I'm going to stop sharing here. Do you guys have any questions that you have? You don't have any questions for me?
I'm good.
Yep. So make sure that 6.3, make sure you understand the x and y, and then y and r, those things, and then also understand the 30, 45, 60, the exact value, the table. Those are very, very important. Okay. So I'm going to start recording.